Good morning, dear students. Today we are going to step up into a new lesson, that is new unit, that is polarization. Before knowing this definition of polarization, let's have some basics. We know light is in wave nature, okay? Along with that, we also studied in our uh, previous classes, previous studies, interference and diffraction phenomena. And also we know that light and sounds are travels in transverse in transverse nature in longitudinal nature also, but sound is a longitudinal one. It shows both the phenomenons, that is interference and diffraction. Okay, these two phenomenons exhibited by sound. Then we are concentrating here about the light. Okay, light is in light is a transverse in nature. Somehow we studied. So let's have some illustration. Okay, let's consider longitudinal wave. Longitudinal wave. Okay, to show this, we have to do some experiment. I had a string. The string has fixed at one end, that is D. The another end is free, that I can call it as a C. We know longitudinal wave. Then what is the definition of longitudinal wave? Longitudinal wave in which the wave is parallel to the direction of propagation. Wave is parallel to the direction of propagation. Okay, this is about the longitudinal wave. Then how does it exhibit? Okay, here the atoms will, here is an atom. Okay, atom will moves in a to and fro motion direction like this. It shows the to and fro motion direction. So how it moves in a slit? Let's consider the two slits. Okay, this is the one slit. Let's call this slit as S1. The another slit is here, so that another slit is S2. At the free end, I am going to produce some waves. Which waves? I am going to produce some longitudinal waves. Longitudinal waves, the atoms, okay, or atoms will move in a to and fro motion direction. Okay, so it will passes through slit S1 like that. Similarly, it passes through slit S2 and reach the point D. It will reach the point D. Okay, then just we will modify some slit S1. Okay, another, just we are going to modifying the, if both are parallel, then these waves, longitudinal wave passes from S1 and S2, from S1 and S2, and it will reach to the end D. If I change the slit position of S2, what does happens? Let's see. So the same slit I am going to keep here. I am not going to change this slit S1. Okay, let's tilt this slit S2. Let's tilt this slit S2. Okay, again I am going to produce here longitudinal wave. Then does the waves passes from slit S1 and S2 to the end D? Yes, sure. Because these are parallel in the direction. So the waves will passes through this slit S1 and this slit S2 and it will reach to the point D. So this is about longitudinal wave. Let's consider transverse wave. Okay, before going to know about this transverse wave, let's have in our childhood we all are played with the rope. Okay, uh, the rope which is fixed at one end. Okay, imagine that the one person who is standing here. Okay, the person who is standing here, he is holding uh, rope. He is holding rope. He he moves. Sorry, he the person is holding rope. He just going to shake this rope. The rope will shows this type of wave. Then this type of wave is called as transverse wave. So how can we define this transverse wave? Transverse wave in which the waves are perpendicular to the direction of propagation. Waves are perpendicular to the direction of propagation. Okay, this is transverse wave. So the same wave we are going to consider here. Okay, again this is the point C and this is the fixed point D. Again I am taking the same slits S1 and S2. If I produce the transverse waves at the point C, the slit S1 and S2 are parallel to each other. Okay, if we produce transverse wave, they will reach in this direction. The both the wave, sorry, the transverse wave which passes through S1 and S2 and reach to the fixed end. Here the angle is at the 90 degree. Then we have to indicate this transverse wave in this form. Okay, then the another case is here. So if I tilt the slit S2, what does happens? I'm keeping the slit S1 as it is, then just we are tilting the slit S2. Okay, then does the wave pass from slit S1 to S2 if we produce the transverse waves? Yes, they passes through slit S2 with which will they passes, but the amplitude of the wave will decrease. Surely the transverse wave will passes from S1 to S2. While moving to S2, the amplitude of the wave will be decreases. Then one more illustration we will do. The same point C. Okay, this is the fixed end D, this is the free end of the string. Here the at the C, this is a CD is a string, D is a fixed point, C is a free point. Okay, you can okay, let me, the one more slit I am going to keep. Only here I am using only one slit S. Okay, here I am going to produce both the waves, longitudinal wave as well as transverse wave. does all the waves will does all the waves does passes through this slit S? Let's produce some waves here. So this is, I'm going to produce here, I'm going to produce first transverse wave, then longitudinal wave. This transverse wave I am going to produce, sorry, here we have to produce this transverse wave. Parallel wave, of course it passes from sorry, it passes through the slit. Yes, the transverse wave, the direction, once I am going to pass produce the transverse wave in this direction, which is parallel to this sorry, which is perpendicular to this paper, then the direction, the perpendicular direction, little I am going to change in this direction. So the wave will be like this. Okay, the wave will be like this. The some more somehow in another direction I am going to produce like this. Okay, does all the waves, all the perpendicular waves, does reaches this point? No, only some wave, which is some wave will pass through the slit. Yes, that means the polarization will takes place. Then what is this polarization? This slit will restrict some waves to pass through this. Here it restrict ಮಾಡ್ತೈತಿ ಇಲ್ಲಿ. So it restrict. Okay, the vibration, many vibrations will many transverse wave, the vibrations in different directions we are produced here. Only certain types of waves will pass through the slit. Yes, so this phenomenon is called as polarization. Then what is the definition of polarization? Polarization is the to restrict the vibration, to restrict the vibrations in particular plane, particular plane of the of transverse wave, particular 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 wave of transverse wave. Okay, this is about the polarization. Then one more is here, to restrict actually then before going to uh, let's have some other basics about light. uh, light light have some more definitions I am going to tell you here. Light is a electromagnetic wave that we know. Electromagnetic wave means this is the electric wave and this are the magnetic wave. This shows the electric wave and this is the magnetic wave. In the optical light, just we are considering like this. Then how light produced? Can you think how light is produced? The sources we know. Light is produced by spontaneous emission. Light is produced by spontaneous emission. Then what is this spontaneous emission? We know atoms, many atoms we know. So there is a ground state and excited state. Okay, the ground state, and this is the excited state, and this is the ground state. Okay, the atoms will be in the ground state. When they goes to the higher energy state, there they will stay about 10 to the power minus 6 seconds. While after 10 to the power minus 6 seconds, again it will come back to the ground state. While coming from excited state to the ground state, they produce, or else they loses some rays, that is nothing but light. Okay, then one simple example. This is only, I said only about this single atom. Let's consider a blacksmith. Many of we had seen in the market, the blacksmiths, uh, they are heating up iron. It will after some time it will turn into red color. Okay, why does it red color? Because the heating process is the giving energy to the iron molecules. After getting energy, they moves to the higher energy state. While coming back to the ground state, it produces light. Even in nature also, the continuous n number of atoms will goes to higher energy state, while that coming from the higher energy state to the ground energy state, they emit light. Okay, why we know why iron is red now. So then